Okay, in this video we're gonna try to demonstrate how we can calculate the accumulated value for different interest rates compounded monthly between the times of 5 to 40 years. We will also graph information. I've already prepared a sheet that presents this graphically. Here is the sheet. So we're going to try to obtain this graph along with the computation that is here. This is very useful when you're comparing different interest rates. So let's see how this works. First, let's define the principal. I will enter 10,000 here. Notice that it doesn't give you money, so we'll change it to currency. We will now enter the interest rates. Notice that when I enter the interest rates, I'll enter 0.06 because that is equivalent to 6%. It doesn't change it to a percentage, but we're going to figure it out. 0.08 for 8%, 0.10 for 10%, and 0.12 for 12%. We select all the cells and we format it using the percent style, and that gives us the respective percentages. Notice that I've already centered the cells, but if it's not centered or it's in this format, just click center. Let's now enter the time in years. So we go 5, 10, 15, 20, 25, 30, 35, and 40. You can center these as well. Remember that the accumulated value formula for compounding is given by AV equals to P times 1 plus I to the n. So that's what we're going to try to represent here. Let's try to format this just a little bit more so it's more evident. So we're going to enter this in our cells. So right now I'll explain what it means. Remember that every formula starts with an equal sign, so we start with that. The dollar signs here represents that the value at B6 will be taken absolute, meaning that this will never change, and that has to be the case because the $10,000 is the principal. So we make that a value that doesn't change. So this is the P, the asterisk means the times, open parenthesis 1 plus I. Now I is equivalent to B8 over 12. Notice though that there's a dollar sign in front of the 8. What does that mean? That means that we don't want to change the interest rate, but we want to be able to change the entries, the other entries. Similarly for A9, A9 represents the years, and the reason why we multiply by 12 because the total number of interest periods is equivalent to the frequency of conversion times the number of years. So in this case, we'll be multiplying the entries in A9 with 12, since that is the frequency of conversion monthly. That will give us 13,488.50. To obtain the rest of the cells, what we're going to do is select the first cell and drag down the formula. This will create a series that will autofill with the same formula. Notice that this number is too big, so we're going to expand it by double clicking here. We now take the entire cells from B9 to B16 and we drag it. This will then fill out the rest of the cells and create the computation. Notice though that they are not filled up, so we're going to expand them. Since all the columns have been selected, it should expand automatically. And we have the entries. Let's rename this to OPA1Y for Y for the YouTube video. Let's now create the graph. To create the line graph that we see here on this example, we will use only the values shown here. So we select all of them. We start from B9 to E16. Go to insert, line graphs. We can select several options, but this one is fine. And we obtain this. So notice though that this is very different from the original graph that we have here. So we're going to change that to letter 1. It's change first the title. You can change the title. That's not hard. I've already created it here, but you can type it in. So we double click here. Notice that there are no axis titles, but we're going to enter that right now. Add chart elements, axis titles, primary, and both primary, horizontal and vertical. This is the label for the vertical axis. This one represents the years. Let's expand the graph just to make it a little bit bigger. We will now adjust the layout by changing the grid lines. We want to change the label for the horizontal axis. So we're going to format that. We're going to select the first column. Let's change the series name one time since we're here. The reason why is because it only has title series 1, series 2, series 3, series 4. So we want to make those adjustments. So series 1 is for 6%. Sorry, 6%. Series 2 is for 8%. Series 3 is for 10%. And series 4 is for 12%. Click OK. That makes the adjustments. Let us change the intervals for the axis. So in the original example, I have 100,000 as a major and 1.2 times 10 to the 6th. So let's make those adjustments here. Why 1.2? Because the biggest is 1.1. The 500,000 is too big. Just notice the differences. So let's change this to 100,000. Make it a little bit bigger, and we are finished with this. Can make other aesthetic adjustments, but this is enough. So here we have the years and the accumulated value. Clearly we can see that as the interest rate grows, we should be able to see that the higher the interest rate, the more we obtain over the number of years. That concludes the video for this problem. So we were looking for analyzing the trends for the different interest rates and the years between 5 to 40 years.